All right, today we're putting on our detective hats. We're going to dive into something called exploratory data analysis, which, sounds kind of fancy, but it's really just about learning how to listen to data to find the incredible stories that are hiding inside. So let's start our investigation.
I mean, think about it. You get a data set, could be sales numbers, scientific readings, anything. At first, it's just a wall of numbers and text, right? It's chaos. But buried in there are patterns, secrets, and some really surprising truths. So the first, most important thing we can do is just ask, what story is in here? Just waiting for us to find it. So here's our game plan. We'll start with the mystery itself, then we'll find some early clues, learn a powerful new visual language, build our story piece by piece, and wrap it all up with a big reveal. Okay, so first things first, what exactly is this exploratory data analysis thing we're talking about? People usually just call it EDA for short. The best way to think about it is like it's the first time you read through a new book. You're not stopping to analyze every single word for its deep symbolic meaning, not yet. You're just getting a feel for it. Who are the main characters? What's the setting? What's the basic plot? It's that first pass that gives you the lay of the land before you can do anything deeper. So what's the point of all this? Well, we want to understand the main story, of course. We want to spot any obvious patterns or trends. We're also looking for problems, like weird outliers that don't fit. And all of this whole initial look, is what guides every single thing we do next. If you skip EDA, you're pretty much flying blind. Okay, so every good detective needs a case file. And for our investigation today, we're going to use a real classic. It's called the Gapminder dataset, and it's absolutely packed with fascinating info about our world. So what's actually in this file? Well, we've got data for a ton of different countries, across different continents, over a bunch of years. The main clues we're going to focus on are life expectancy, population, and GDP per capita, which is basically just a measure of a country's wealth per person. All right, clue number one. We can run a quick calculation and find the median life expectancy across everything in our dataset. And it turns out to be about 60.7 years. So there we go. That single number gives us a starting point, a first piece of our puzzle. Let's pull another clue. The average GDP per capita is around $7,215. Okay, so we've got two numbers now, a typical lifespan and a typical income. But is that it? Is that really the whole story? Does this actually tell us what's going on? Or could these numbers be hiding something important? And this gets us to a really, really crucial point. These summary numbers are useful, for sure, but they absolutely cannot tell you everything. In fact, sometimes they can be totally misleading. You can have two completely different situations that have the exact same average. So to really get the story, we need a better tool. We need to actually see the data. And that brings us to our big breakthrough. We've got to move beyond just looking at numbers on a spreadsheet. We need to learn a whole new visual language. This language is built on a really powerful idea called the grammar of graphics. And honestly, it's going to change the way you see data forever. Now, the tool we'll use to speak this language is called ggplot, but don't think of it as just another piece of software. It's more like a philosophy. It's a complete system for thinking about and building graphs piece by piece, almost like you'd build a sentence out of words. And this whole grammar thing sounds complicated, but it really breaks down into 5 simple parts. First, you have your data. That's easy enough. Then you pick your geoms. Those are just the shapes, like points for a scatter plot or bars for a bar chart. Now, the real magic happens with aesthetics, where you map your data to things you can see, like color or size. Then you can use facets to create little mini charts, and finally, themes to make it all look nice and clean. Okay, enough theory. Let's actually put this grammar to work. We're going to build one single visualization step by step in 5 acts. And you'll see how a really simple chart can grow into a rich, compelling story. Act 1, the opening scene. We start with the absolute basics. We just tell our system, take the Gapminder data, put GDP on the bottom axis, life expectancy on the side axis, and use points as our shape. If we plotted that, we'd get a simple scatter plot, and we'd see a pretty clear trend right away. As countries get wealthier, people tend to live longer. Now for Act 2. The plot thickens. We add one tiny instruction, map the continent data to the color of the points. And just like that, bam, the plot just springs to life. We're not looking at one big blob anymore. We're suddenly seeing 5 different stories, one for each continent, all happening at the same time. For Act 3, we use that facet tool I mentioned. This is so powerful. It takes our one plot and breaks it apart into a grid of smaller subplots, giving each continent its own stage. Now we can compare the trend in Asia directly to the trend in Africa, side by side, all in one view. In Act 4, let's add another layer, a trend line. This is just a statistical layer that helps our eyes see the underlying pattern in all that noise. It confirms what we suspected. There's a strong positive relationship between wealth and health on pretty much every continent. And for our grand finale, Act 5, the polish. We apply a clean, simple theme to get rid of all the distracting grid lines and gray backgrounds. This makes the data the absolute star of the show. And there you have it. We went from a boring cloud of points to a clear, insightful visual story in 5 logical steps. So, we've just seen how to build a story with data. Now for the big reveal. Let's talk about why this is so incredibly critical before we use our new skills to get a true bird's eye view of the world. But first, I have to show you this really quick but totally fascinating detour. It's a famous cautionary tale in the data world, and it proves, beyond a shadow of a doubt, why just looking at your data is something you absolutely cannot skip. So check this out. It's a famous example where you have a bunch of different data sets that, on paper, look exactly the same. They have the same average, the same standard deviation, the same correlation. All the summary numbers are identical. So you'd think the data is the same, right? But the moment you actually visualize them, you see the truth. They tell wildly different stories. One's a dinosaur. This is known as the Datasaurus surprise, and it proves one thing. Numbers alone can lie, but seeing is believing. So, armed with that knowledge, knowing how vital it is to actually see our data, we can take things even further. We could merge our Gapminder data with a world map and create a powerful visualization showing exactly how life expectancy changes across the globe in a given year. This would reveal huge global patterns that were totally invisible in that original table of numbers. So think about where we started. We had this messy, confusing table of numbers. And now, just by learning to speak this visual language, we've uncovered a clear, layered story about global health and wealth. This whole idea of exploratory data analysis, it's not just about making pretty charts. It's about creating real understanding. So the only question left is, now that you can see the story, what will you uncover?